Welcome to today's Statistics and Probability lecture. Today we're going to be looking at how to solve conditional probability problems using tree diagrams. Let's look at our first example. This one says, in a bag I have 5 green marbles and 3 red marbles. What is the probability of drawing a second green marble given a green marble was drawn first without replacement? So let's write down what we've been given. We have 5 green marbles and 3 red marbles. So that means I'm going to have a total of 8 marbles. So 8 possible outcomes is going to be my sample space. So that tells me that my probability of drawing a green is going to be 5 out of 8. And the probability of drawing a red is going to be 3 out of 8. Now the problem wants to know what is the probability of drawing a green given a green marble was drawn on the first without replacement. So we'll denote these with a 1 and a 2 to distinguish the first draw and the second draw. This tells us it was drawn without replacement. So this is without replacement, which means these are dependent events. And that tells us that after I draw my first marble, I'm going to leave that marble out, and my total number of outcomes is going to decrease by 1, and whatever color I drew, that is also going to decrease by 1. So let's use a tree diagram to help us solve this conditional probability. On my first draw, I have the possibility of drawing a green at 5 over 8 probability, and I have the possibility of drawing a red at 3 out of 8 probability. Then I'm going to do my second draw, and with each of these I'm going to have the probability of a green or red. So if I draw a green, then my probability is going to be 4 over 7 on my second draw. If I draw a red, my green is going to be a 5 over 7. If I draw a green, then my probability of drawing a red is going to be 3 out of 7. And if I draw a red first, my probability of drawing a red is going to be 2 out of 7. So now that I have my tree diagram to show me how the probabilities are going to flow, let's answer this question of what is the probability of drawing a second green given that I drew a green on the first try. So let's look at this and see what does that mean. What this is saying is that on my first try I drew a green. So this is what I'm given, and I want to know what is the likelihood that I'm going to draw another green, and that's this probability right here. The probability of drawing a second green when I drew a first is just 4 over 7, and that equals 0.5714, which means that equals 57.14%. There is a 57.14% probability that if I drew a green on my first try, then I will draw a second on my second try. So now let's look at the same problem, but this time we're going to use the formula for getting conditional probability to solve it. The formula for finding the probability of G2 given G1 is the probability of G1 and G2 divided by the probability of G1. And that equals the probability of G1, G2 divided by the probability of G1, G2 plus the probability of G1, R2. So let's use our tree diagram to help us understand what does that mean and what numbers do we want to use. So let's look at this first one. Which is the probability of G1, G2. So that is going to be these two numbers multiplied by each other. So that is going to equal 5/8 times 4/7. Now on the denominator, we are looking at the sample space that includes G. So what that is including all of this space right here, all of the probability of G. This is my sample space that includes G. And we're first going to write what we just did, our G1 and G2. So that's going to be 5/8 times 4/7. And then we also need to account for the possibility that if I draw a green one at the first draw, I'm going to draw a red one. So that is this probability. So that is going to be 5/8 times 3/7. And now the next thing we need to do is we just need to do some algebra and move things around to finish solving for our problem. We've got 5/8 times 4/7 on the top. I've got both of my terms are multiplied by a 5/8, so I'm going to use algebra and just pull that out. Combine my like terms, then I've got 4/7 plus 3/7. My 5/8 is on the top is going to cancel out with the 5/8 on the bottom. That gives me 4/7 on the top. 4/7 plus 3/7 equals 7/7, and that simplifies to 1. So 4/7 divided by 1 equals 4/7, which is what we got previously, and then we saw that that simplifies to 0.5714, which is 57.14%. So we got the same answer that we did before, that our probability of drawing a green marble on our second try when I was given a green on the first when we used the formula. Okay, let's look at the same problem, but this time let's look at the probability that we are going to draw a green on the second, given that we drew a red on the first. So looking at our tree diagram, it's going to be the exact same that we did on the last problem, but this time we are going to draw a red first, and then we want to know what is the likelihood that if I draw a red first, that I'm going to draw a green. And that's my probability. So the probability of drawing a green if I draw a red first is going to be 5 out of 7. And that equals 0.7143, which equals 71.43%. So I have a 71.43% probability that I will choose a green given that I chose a red first. Now let's solve this problem using the formula. So I want to solve for the probability that I will draw a green on the second try given that I drew a red on the first. So that is the probability of drawing a red and a green divided by the probability of drawing a red. And that is the probability of drawing a red, green divided by the probability of drawing a red, green plus the probability of drawing a red, red. So once again, let's visually look at the sample space so we can see what it is that we are drawing, or what is it that we're calculating. So the first thing that we're looking at is we want to draw a red and then a green. So that is this right here. So we're going to put those numbers on the top. So that's going to be 3.8 for my red and 5.7 for the bottom for my green. And then this bottom number, the denominator, that is the sample space for drawing a red. And that includes everything in here. So we're first going to write down the probability of drawing a red and then a green. And then we want the probability of drawing 2 reds. Then once again, we're going to use algebra just to move things around to help us to simplify. The denominators are both multiplied by a 3/8, so I can pull that out. Combine terms, my 3/8 on the top cancels out the 3/8 on the bottom. That gives me 5/7. 5/7 plus 2/7 equals 7/7, and that simplifies to 1. It's going to give me a probability of 5/7, which is what we calculated before, and that calculates to a 0.7143, which equals 71.43%. So that tells me I have a 71.43% that if I draw a red on the first draw, that I have a 71.43% probability that if I'm given a red marble on the first draw, that I will be able to draw a green on the second draw. So this is how we do conditional probability using tree diagrams. See the links below for additional supports and resources. Be sure to like and subscribe to get the latest videos by Caz Academy, and I'll see you at the next video. Thanks for watching.